Hello and welcome. This is your recap of the intro to circular motion. In this unit, we're going to talk about three things. Things that revolve, things that rotate around other things, and then the cause of rotation, which is torque. In the introduction part, we're going to review some geometric and then pre-calculus kind of algebra / pre-calculus notions that are very important for this unit. So we shall start with pi. What is pi? Pi is a ratio of circumference to diameter, hence the C to D. That's C for circumference, D to diameter. Basically, if you take any circle, no matter how big or small, and you take the measurement, how long the circumference is, and divide it by the diameter, this connection is pi. Circumference is pi times diameter. More popular is the formula of 2 pi r. Why is that? Because diameter is 2 radii, two opposite parts of the circle going through its center. Hence, this right here is radius, but this whole thing right there would be the diameter, which is 2 radii. Then we continue talking about circle and the angles that are inside it. So you know an open angle, if I talk about an open angle, I'm thinking about one line. All of these are 180 degrees. That's half of a turn. The full turn will be 360. So the entire circle comprises 360 degrees inside it. Half of a circle is 180. So up till now we had been using angles measured in degrees. Now we're going to dip into unit circle. So for example, if an angle, let's say this angle, just eyeballing it, is about 50 degrees, there is another way to measure angles, and that would be in radian. What is 1 radian in terms of degrees? How big is 1 radian? If you think of a circle again, get the center of that circle, and from that center, open up an angle like so. If this arc right here on the outside, the length of this arc equals the radius, then this angle inside is exactly 1 radian. Think about it as a piece of pizza. So this piece of pizza would have the angle inside it that equals 1 radian if the crust and the length of this, which is the radius of the pizza, if they are equal, then this angle right here is exactly 1 radian. We practice how to convert degrees to radians. So we started with, that's our illustration of 1 radian. How many radians are in full turn? So we said it was 360 degrees, and it also is 2 pi radians. So in other words, what is a pi? You remember that's the ratio of circumference to diameter. And you also know that pi, if we just round it to 3 sig figs, is 3.14. So then 2 pi is about 2 times 314 is going to be 628. When I say 2 pi radians, it's about 6.28 of those radians are in 360. Convert pi radians to degrees then. 2 pi radians is 360. Then pi radians is half of that, so that's 180 degrees. 2 pi radians is 360 degrees. Then just pi radians is going to be half of that, which is 180 degrees. Now, how many degrees is 1 radian? Not 1 pi radian, but 1 radian. 1 radian would be 180 divided by pi. So it's 180 divided by 314. If you take your calculator and divide 180, that's degrees, by pi, you will get about 57.3 degrees. Because 180 divided by 3 would be 60. This is a little more than 3, so therefore your angle is a little less than 60. So 57.3, this 1 radian is 57.3 degrees. And we practiced after that how to convert radians to degrees and degrees to radians. For example, what is 60 degrees in radians? The way to set it up, you go for 180 is 2 pi as like 60 to what? And then you start cross multiplying. 60 times pi equals question mark times 180. So then question mark is going to be 60 pi divided by 180. That's pi divided by 3. So that is what 60 degrees are in radians. That's going to be pi over 3 radians. Now, what is pi over 4? So I know that pi is to 180 as pi over 4 to question mark. Well, looking at this, looks like if I just divide 180 by 4, I should get my answer. 180 divided by 4 gets me 45 degrees. So the answer of what is pi over 4? That is going to be 45 degrees. And after that, we practiced converting radians to degrees and degrees to radians. If I want to go from degrees to radians, I'm going to say 180 is to pi radians is like my input in degrees to question mark. And then I cross multiply. When I cross multiply, I have these two multiplied by each other and then divided by 180. So my question mark is going to be this pi times my input in degrees divided by 180. Say I want to convert 70 degrees, 120 degrees, 270 degrees, for example, to radians. It's going to be 70 divided by 180 times pi radians. That's the answer. 120 to 180 pi radians. 270 divided by 180 pi radians. If I want to convert radians to degrees, it's a similar setup with just what we have on the left and what we have on the right is going to switch. So if I want to go radians to degrees, I know for sure that pi rads is 180. So then my input in rads is going to be question mark. Cross multiplication again, 180 times my input divided by pi, and that would be my answer in degrees. Let's practice. What is 3 pi radians in degrees? What is 7 pi radians in degrees? Maybe not pi. Let's say I want 10 radians converted to degrees. 180 divided by pi times 3 pi. 3 times 180 is 540 degrees. 7 pi radians to degrees. 7 pi, you take your 7 pi, you multiply it by 180, and you divide it by pi. So that gets you 7 times 180. 10 radians. Now see, here I don't have the pi, but I still do it the same way. So I'm going to multiply 10 times 180 and then divide it by pi. And that would get you your answer in degrees, answer in degrees. So this completes the conversion between radians and degrees. After that, we talked about angular versus linear quantities like distance, displacement, and velocity. I'll see you in the next video for that.